So I'm watching for the meniscus because liquids tend to be cohesive and adhesive, but since they're cohesive, they sort of hold on to the edge. But that's why I look at the meniscus because there's like a bit of a range, and it's exactly at 20, so we Gucci.
The footage of our notebook. Let's start in the top left corner. We're going to look at our volume of water. So we started with the final volume, and we subtracted the initial volume in our graduated cylinder, and ended up with 6.50 milliliters of water. The beaker weighed 88.466 grams. The mass of the water plus the beaker weighed 94.786 grams. We subtracted the mass of the beaker and the water. We subtracted the mass of the beaker from the mass of the beaker and the water. We came out with 6.320 grams, which gives us the mass of the water. We divided 6.320 grams by the volume of the water, which was 6.50 milliliters, and we got almost 1, which is the density of water. Now let's go under our little divide in the page here. We're going to start with our data. We started at 0 milliliters, which is at the very bottom. Our total volume was 20 milliliters, and our concentration was 20%. Our density was 1.17 grams over milliliters. We added 5 milliliters of solution. Our concentration became 16%. Our density became 1.074. We added 5 more milliliters, giving us 10 milliliters of water, 30 milliliters of total volume, giving us a 13.3% concentration and a 1.059 grams over milliliters density. We added 5 more milliliters, giving us 15 milliliters total in water, 35 milliliters total volume all over, giving us an 11.4% concentration and a density of 1.029 grams over milliliters. Notice our density and our concentration became less and less as we added more water, aka a dilution. To find our unknown, we did basically the same thing. We weighed our graduated cylinder, found it to be 60.732 grams. We had 50 milliliters of unknown, so it was very simple. We just had to find the mass of the cylinder plus the unknown, which is 113.724 grams. We subtracted the mass of the graduated cylinder from that and got the mass of our unknown, which is 52.992 grams. We divided the mass of the the mass of the unknown by the volume of the unknown, and came out with a density of 1.0598 grams over milliliters, or a concentration of about 13%.
So this is the comparison between our stock solution concentration and our dilution concentration. So we have 4 different variables. We have the concentration of the first solution, we have the volume of the first solution, the concentration of the second solution, which is our unknown, and then the volume of the second solution. So this is going to be our constant because this is our first solution for everything. So this is where our equations are actually related. So they will both, you're dividing 20, or you're multiplying 20% by 20 in both equations. So for this side, our volume is going to be 25. We're going to divide 25 on both sides by 4, which is what our constant is. We're going to multiply that by 100 because we divided by 100 right here. So we got to get it back to the regular percentage. So we're going to end up with our concentration of our second solution, or the first solution, our stock solution, as 16%. So our dilution will be similar. We're going to take 35 milliliters because we diluted it with 10 milliliters of our blue water. And then we're going to divide 35 on both sides. We're going to divide the constant by 35 to get 0.114. We're going to multiply that one by 100 because we divided this by 100 right here. And then we're going to end up with 11.4%. So our dilution is going to have an 11.4% concentration in 35 milliliters.
We're gonna speed this up by like 8 times.